In this series we're going to look at installing and setting up the Raspberry Pi. We're then going to expand the series into a general purpose Linux tutorial series, although there will be some specific actions which we take specifically because we're using a Raspberry Pi. But most of the information provided will be able to be used in many different versions of Linux. Once you've bought your Raspberry Pi, the first thing that you're going to want to do is download and install the operating system. So to do that, you go to raspberrypi.org and click Downloads. If you know which operating system you specifically want, you can select that from the list here. If however you're likely to want to explore and use different types of operating system, you can just use the Noob system, the Noob out-of-box software system. This software includes images for all of the main Raspberry Pi installations, and you can use it to switch between operating systems on the fly, rather than tying yourself into a specific operating system. For the purposes of this video I'm going to be using Noobs, and so I'll just download the zip file for this. We're also going to want to follow this setup guide. This basically gives you a link to some software which is available on the SD Card Association website, and it's called SD Formatter 4.0, or there may be a later version by the time you see this. So we'll also download this. The link for the download is on the left here. And you obviously need to agree to this license, which I already have read. And that will start the download. Because we want to use our SD drive as our actual boot drive, rather than just a data drive, we do need to use the SD formatter tool to format the SD card properly. So to do that, I'm just going to open up this file and run the setup.exe. I'm just going to click through the options to install it. And then this has created a new option on my desktop to install this. So I happen to know that F is my SD card already. Although I would encourage you to check that this is the correct location by pressing the Windows key and D to display Windows Explorer, and double checking that this is the SD card that you want to install the operating system to. We're just going to leave all of the options the same. We're not going to worry about changing these, and we're just going to click Format. And that's just going to go ahead and format it for us using the FAT32 file system. If we head back across to our browser, we can see that the next step is to drag and drop new files. So once the SD card's been formatted, we just drag and drop all of the extracted files directly onto the SD card. So we can open up this folder which has just finished downloading, and we can also open up our Windows Explorer again. And we're simply going to drag and drop all of that files across. This step may take quite a while because there is a lot of files that need to be transferred, and the speed that files can be written to the SD card is not very fast. So I'm going to speed this part of the video up, although as you can see it can take about 5 minutes for this step to complete. So now that that step's finished, we can remove our SD card from our main computer, install it into our Raspberry Pi, and turn the power on for the first time. When we first load up the Raspberry Pi, this is the screen that we're going to be displayed. As you can see, it gives us the options for all of the different operating systems which were available to us on the Raspberry Pi website. We could, for example, install Raspbian or any of the others. Each of them have different specific purposes. We're going to install Raspbian, which is the recommended one in this case, And to install it, all we need to do is select the button on the left, select the install button, and then click OK. This next step in the process can take quite a long time. Again, like when we were transferring the files onto the SD card, this part of the process can take up to about 20 minutes. And this is primarily because the SD card in itself is a very slow storage device in terms of read-write speed. So again, I'm going to speed this part of the video up, and I'll bring you back in when the installation is complete. So as you can see, we're now presented with this OS is installed successfully. As I mentioned earlier, we can install multiple OSs and switch between them. But in our case, we've only installed the one operating system, and so we can just click OK. This is basically the equivalent of the Windows boot up sequence, although this is the Linux version obviously, and it will take a few moments to actually load up, especially during the first boot up when it's still setting up some of the files. Before it allows us to do anything with the operating system itself, it does present us with this configuration screen, and we can go through all of the options here and just briefly talk about what each one does. So first off, we have expand file system. This is not going to be supported with noobs because of the way noobs works, in that it creates multiple partitions for different operating systems, as well as creating a partition specifically for itself. But in a full installation of Debian particularly, you would use this to make sure that you're using all of the space available on your hard drive. The next option available to us is the change user password option. Out of the box, the default user is Pi, with the password Raspberry. In order to change this, it's just a matter of pressing enter to open up the next screens, which will then ask you for the password. If you type the password, you won't actually see it displayed on screen as you're typing. This is a feature of Unix, and it is common across most terminal logins, so it's not a matter of your keyboard isn't working. Unix is deliberately not telling you that any input has been recorded. If you need an example of where this may be useful, it could be useful if you were sitting in a cubicle, for example, with other people around you, and you would want to obviously protect them from seeing the length of your password, which could then be used to guess your actual password itself. So I'm just going to change the password now. But remember that if you don't change the password, the default password is Raspberry. So the next option is whether to enable boot to desktop or directly into Scratch. For my purposes, I'm going to keep this as being the command line. I don't want to boot directly into Scratch or directly to the desktop, but depending on your use case, you may want to do that. The next option is the internationalization options. This is just a matter of changing the language. Because this is already in the correct language for me, I'm going to leave this alone. But obviously, if you need to change this, you can use this option to change it. The Raspberry Pi enables you to use a camera directly from the hardware. If you want to use this, you will need to connect the hardware and go through the process of enabling the camera in this setting. Without enabling this setting, the Raspberry Pi won't be able to identify the camera at all. Option number 6 is a method that the Raspberry Pi Foundation can track where Raspberry Pis are being used by mapping it online. I'm not going to want to use my bandwidth to track this, and so I'm going to leave this disabled. But again, if you want to, you can go through the options to enable this here. We then have option number 7, which is overclocking. The Raspberry Pi can be overclocked quite significantly, if that's what you want to use it for, but overclocking does come at a penalty. For example, it will decrease the lifespan of the Raspberry Pi. In our case, that's not going to be something that we want to do. We want our system to be stable and always on, and hopefully last for quite a while. And so I'm not going to delve into the overclocking functionality, although there are quite a lot of options available to you if you do want to overclock it. We then have the option Advanced Options. This will take us through to a separate menu, which will allow us to configure some of the more esoteric options. For example, overscanning is a function that is very rarely used in these days. It was originally a method to display the screen on a CRT monitor without leaving black bars around the edges. But if you're using a modern LCD screen or anything which is not a CRT screen basically, it's unlikely that you will encounter this. The next option is the host name. This is basically the name of this machine. If you had multiple machines on your network, you may want to use host names to identify which machine specifically you're using at the time. This is useful later on when we start looking at SSH and VNC software, because it allows us to actually identify the machine that we're using from software, rather than actually looking at which machine is connected at a specific time. By default, our hostname is Raspberry Pi. I am going to change this, however, to Workspace, because that will actually suit my specific needs better. But you could of course leave this as Raspberry Pi or change it to anything else that you may want. We then have an option to split the memory to enable better GPU performance. We're not going to be using our Raspberry Pi for anything GPU intensive, and so I'm not going to delve into this option in too much detail, other than to acknowledge the fact that it is here, and if you do want to use your Raspberry Pi for something GPU intensive, you may wish to consider taking advantage of this option. The next option is SSH, which is by default disabled. We're going to want to enable this so that we can connect to our Raspberry Pi from another computer. We then have three more options. We have an option for SPI, which isn't required for things like PiFace, which is not something that we're going to be using, and so we will leave this disabled. We then have an option for audio, which we can either force through the HDMI cable or through a separate 3.5mm jack. We're not really worried about audio for our example, and so I'm not going to worry about updating this. But you could of course change this to suit your preferences if you wanted to use headphones, for example, for whatever application you were using your Raspberry Pi for. We also have an update option, which will just update our software to the latest version. We're not going to worry about that just yet. Instead, we're going to go back into our main menu and save our changes. We're then going to be asked whether we want to reboot our Raspberry Pi, and we will select yes. As with the boot up process, the shutdown process takes a few moments as well. This is just so that the Raspberry Pi can actually save all of the information and all of the changes that we've made. After we've restarted our Raspberry Pi, we obviously then have the boot up process. This again will take a few moments to go through, but will hopefully be quicker than last time, because we've now instantiated a lot of the information that we're going to need. We will then be presented with this Workspace login request, Workspace being the host name of this machine, and so we can log in for the very first time. Our username is going to be Pi, and because we have changed our passwords, we will use the new password which we recorded, although by default this will be Raspberry. Typing this information will obviously log us in, and will present us with our new terminal screen from where we can do whatever we want with our Raspberry Pi. So if we press Ctrl L, that's going to clear the screen for us. That's a command which will be very useful to a lot of people who are new to Linux, because it allows us to keep in context exactly what is being displayed on screen. For example, if I try to display a list of all of the files within the root directory, that's all that's going to be displayed on screen at the moment. If I press Ctrl L again, that information is going to disappear. So assuming we have a network connection at the moment, the next command that we're going to do is called sudo apt-get update. This is roughly the equivalent to Windows Update, in that it's going to check how many packages are installed and check whether there are any updates available for those packages. Unlike Windows Update, however, this is not an automatic process. Linux is intended to be run on servers, and so updating automatically could cause conflicts with other pieces of software. And so updates are normally done manually within Linux, which is why we have this command. The very first time that you run this command, it can take quite a long time, because there are a lot of different packages that need to be verified. Once the sudo apt-update command has finished, we're roughly at the same point as Windows telling us that updates are available, and so we can go ahead and install those updates by typing sudo apt-get upgrade. If we hit enter now, we're going to check all of the packages, and then we're going to eventually be presented with a prompt asking us whether we want to install them, after the system has calculated how much additional space it will require. In this case, I'm just going to click yes. And then the system is going to go ahead and install any updates. The first time that these two processes are run, the entire process can take upwards of 20 minutes. And this is because there are a lot of updates to a lot of different packages within Linux. After this first run, however, the entire process is normally a lot quicker. But it is important to note that this footage is sped up because of the fact it does take so long. Once the upgrade process is complete, you are able to do anything that you want within Linux. For example, if you want to list all of the files on the computer in the root directory, we can do that. That's not a problem. In the next video, we're going to go through some of the more basic commands within Linux to help people who haven't used Linux before get started. So make sure you're subscribed so that you don't miss out.